Okay, are we online? Hello, hello, hello. It seems to be online. Yep. It looks okay. All right, let's get on to business then. Good evening, hello, everybody, joining the second episode of our adventures with pandas to discover the data through the procedures of exploratory data analysis. So first and foremost, thank you to all the patrons and all the supporters that have given me feedback, friends and random people that just happened to come upon this channel. I really do appreciate all the information that you've given me in terms of the sizes and of the text, and since we are still learning how to do this properly in terms of delivery and content, any feedback is more than appreciated. So I do thank you very much. Okay, so today we're going to be dealing with what we call filtering and sorting primarily, but we'll see how far we get with the challenges. The challenges, let me just close this and open a website. The challenges are in the description. So if you have the capacity and the will to stand face to face with them on your own, you can do so and find those through GitHub, download and enjoy them. So without further ado, let's get on to business. Let me check that everything is working, seems to be. If you have any questions, we have a moderator whose nickname is still very difficult to pronounce. So I will speak to him personally to make sure that it's changed to something that we can actually say. So if you have any questions, feel free to ask during the stream as we solve subsequent challenges. And I'll be pausing in between each notebook to check on the chats to see whether there are any questions that we can potentially ask or answer. So with that in mind, good luck and have fun. Today we're going to be, let me know if the size of the text is large enough as well, so I can see, if I can change it and adjust it as you see fit so that everybody can see the same thing. Let me just show you the challenges real quick. Actually, we can just check the history, can't we? Pandas. Let me just check real quick, because I don't know where I stored it somewhere. But anyway, they're in the description. You can check it there to see. Basically, these are sets of challenges from Pandas, all the way from filtering data through merging and dissecting data frames together, all the way up to visualizations and statistics. And we'll be going through as many as we can before we profile our streams. When I say profile, I mean there is a Polish stream and there is an English stream that I'm going to be delivering for Polish stream. It's every Monday at 6 p.m. CEST, and likewise on Thursdays at 6 p.m. CEST we'll be streaming in English. So, all right. Today we'll be dealing with, the first data set that we'll be dealing with is the Euro 12, which is the data set from the European Championships that took place in 2012. And let's have a look at the data set. So we can see that it's a regular CSV files, comma separated, so no tricks there. So let's get on to business straight away. Okay. So we're going to import pandas, as we do. as PD, just to make sure that we have the alias there. And as far as I remember, we can actually borrow, yeah, we can borrow the name from here. So let's just do that. And we're going to call it Euro 12 as they ask us to do. So pd.read CSV and the name of the file. It's we don't need to set any separators or anything because it's already comma separated, and it's by definition a standard for pd.read CSV to import data this way, so we should not have any problems. Okay, and we don't. And let's just check the first 5 rows. Actually, what we're going to do is to view it this way. We have the first 5 rows here, so we kind of flipped it 90 degrees to see exactly what it is that we're dealing with. And we see there's quite a few columns. Some of them goals, shots on target, shots off target, all the statistics per team on their performance in the Euro 2012. Okay, so we see we have some numeric values, we see we have some names of the countries as expected, so nothing too surprising. Okie doke. So let's move on. Select only the goal column, and we could do it this in 2 ways here, typically. The first way is the easier one, but it doesn't always work, and you'll see why in a moment. But we can choose the goal, I think it was goals, yeah, we have an S there. Like this, and this produces a series with just the values from a particular column. And you can see the dot notation here. An alternative that I prefer personally, simply because it's A, cleaner, and B, we don't have to worry about spaces in the column names, as you'll see in a moment, because I see that we have yellow cards and red cards to play around with. And we can print it out this way as well, and it works exactly in the same way. Since I mentioned there is a series there, we can't really do anything from the styles perspective. If you remember from the first episode of the Panda series, we were dealing quite a bit about styles and styling the data frame in terms of coloring the output to see what specific values we have to play around. And we need a data frame for it. So in order to do that, we just do the double brackets, and we see the output is slightly different, and we get a data frame in return. So now we can use the styles, and we can, for example, highlight maps and set the color to dark green because it looks nice on the output. Is everything visible? Can you see it now normally, or should I make the output larger? Let me know in the chat. And you can see that there is an observation that has 12 goals shot. And this is the maximum value of all the observations here. So we have 15 different observations. So there's something that happened that resulted in 12 goals. Okay. Now, how many teams participated? Usually in Euro 20, in any European Championship, there's usually 16 teams. So let's see if that's the case as well. And what's the team? Yeah, team. And we again have a couple ways to look at this, and we do count, and we get 16. We can also do the number of unique values, and we get 16 as well, if we actually comment this out to make sure. Or if you look more from a mathematical perspective, we can actually check the length of a set 12 team. Close this, and we get 16 as well. Set, if you remove the length of it, gives us the unique values. As you know from mathematics, it's only unique values. So if there are any duplications, they'll be removed, and only one instance of it will be stored or saved in a set, as by definition of sets in the mathematical sense. And we can check the length of that set to get 16. So we're good in that. I'm checking every once in a while whether there is anything that we can discuss. So far, so good. Okay, number of columns. We've done this several times already, so I don't think there is much use to discuss this. We just do the shape and check the second argument of the tuple, and that gives us 35 different columns. Okay, so the next task for us is to assign the three columns or variables, team, yellow cards and red cards, to a data frame called discipline. So we have a few things to fulfill here. We have to include these three columns. We have to call it discipline and must be a data frame. So all these elements need to be taken into consideration. So let's do that. Discipline. And we're taking from Euro, we're taking, remember the double square brackets indicate that this is going to be a data frame, and we simply pass on a list to the frame. And you can now see that the yellow cards actually have, let me double check, but yeah, they have a space in between. So the dot notation that we discussed earlier, where is the cards? Yeah, there they are. Yellow cards and then red cards here. The dot notation there wouldn't work anyway, since we're passing a list here, but if we're selecting particular columns, that wouldn't work either. Yellow cards and red cards. Close this, close this, close this, and this discipline. And we have our data set as required. Okay, so now we need a parameterized sort values kind of method, whereby we first sort by the red cards and then we sort by the yellow cards. So we're going to do that, just that, and sort values. And we're going to sort by red cards, and then yellow cards. And we're going to do it top to bottom, so from the most frequent value all the way down to the least. And we do it logically inversely to what we think. So we negate the ascending element as we've seen before. So ascending false, we close this. And now we have the values sorted by red cards first and by the yellow card second. Okay. How many yellow cards by definition of means, or the average of yellow cards given per team? In order to do that, we have to slightly jump ahead, because the plan for the next stream is to discuss the split and combine sort of methodology of data analysis and grouping. But for now, we just need the mean of the yellow cards. So let's do that first, and I'll show you what I mean with the yellow cards, and then we apply the mean method to it, and we get about 7.4 yellow cards overall. But if we wanted to find out, as the question is actually formulated, so how many per team, we simply apply the group by. And again, don't worry about this too much. Now we'll be discussing it as we go along in the next stream. Okay, so the team. So we do this, group by team, select yellow cards and apply the mean method to it, and we have how many of the yellow cards were applied to each of the teams in Euro 2012. Okay. So filter the teams that scored more than 6 goals. We're getting slowly and surely. Let me just rearrange my desk a little, because I want to start drawing to discuss the idea of filtering. And in order to deal with that, or think about this logically, and again, excuse my poor drawings, we need to familiarize ourselves with the concept of a funnel. And again, my drawings are atrocious, as you can see. I'll try and do my best. That's the one. It doesn't look very appealing, but hey, you get the idea. The idea behind it is that we have the data frame here, our data frame Euro 12, and we select step by step. So we select the data frame first, our entire data set. Then we select the column. So we have to tell it that from this data set, we have to apply the column. And then do whatever the operation that is required. So for example, from this data set, in this column, filter out the values that I'm asking for. So in this instance, I need to learn how to draw better funnels. So in this instance, scored then more than 6 goals, we need to tell it that we're giving it this data frame, so our Euro 2012. Then we apply the column, and we need goals because we want to see how many goals were scored. Well, how many times 6 or more goals have been scored, and apply the filter, so anything above 6. And we can see that only Germany and Spain scored this particular thing, had this particular score, and we see that it was 10 and 12 goals respectively. So well done them. I believe, let's test something. We can select the team filter here after this to choose a particular column that we want to find out, and we will get only the names of the teams, of the countries that scored this more than 6 goals, which is as specific an answer as we would like it to be. So we can't really do much better than this. Okay, select columns that start with G. So by the same token, let me check real quick whether there's anything going on. Nope. Okay. So again, Euro 12 teams, or team. Since we know, let me check, Euro 12 team D type. We know it's an object, so we can do string methods on it. So let's do that. So now we need that again. So a string method that's literally spells exactly what we need to do. So select all the observations that start with a G, and we close this, and we see that we get again Germany and Greece. And if we apply the same trick as we did here, so team, we get the Germany and Greece. So only 2 countries whose names start with the letter G apply here. Okie doke. Select the first 7 columns. We're slowly but surely getting to the point where we start filtering and sorting, which is the primary subject of today. Let's see how this is done in our case. Oh, there's some movement here. Okay. No. Okay, my mistake. So, the first 7 columns. Every time we're dealing with the numbers, we want the iloc method. Every time we're dealing with strings, we want the location, so we want the loc method. The I stands for integer. So we're dealing with numeric values here, and we're dealing with text values here. So that's good to remember, so that you don't get confused. You can actually jumble up and mix and match those methods, as we'll potentially see either today or next time. So for now, let's just filter out the 7 columns. So we do Euro 12. Since we're dealing with numbers, we need the iLook method. And now how does iLook work? Again, let me refer back to our beautiful penmanship. Lock and iLook work in logically the same way. So lock and that's a nice sun sign. The first side deals with rows. So you're answering the question, which rows do I want? And you guessed it, the second side deals with which columns do I want? And there is a nice trick with the colon here, which we'll discuss in a moment. I'll just type it up for now. And what just happened? Let me get back to this command here. The colon serves. Think about the colon as if it was some kind of a gateway. So it basically keeps track of what it is that you want on either side, and lets go of whatever is on the other on the respective side. So what do I mean? If we have a number on this side as opposed to the number this side, the gateway points to the direction that it's let to point, that is allowed to point, in other words. So if we limit this on the left-hand side, it will collect everything from this number, so from the limitation here, till the end. And if we put the limitation on the right-hand side, it will look left. So it looks right or looks left depending on where the limitation is. And if we limit the colon from both sides, it will only look as far as you let them. So by this definition, we let the and one more important thing: if you leave it alone as it is, it will look both ways all the way until it stops seeing the data. So that's the idea here. Okay, so in this case, what we've done is we've let it, again, remember, which rows do I want, which columns do I want. So in this case, we let the gateway to see all the rows, and we let the gateway see everything up to column 7. It's really column 6, but because it's 0 counted, Python is 0 indexed, 7 means 0 through 6. So it's still first 7 columns, but the logic here is slightly different. Right? Okay. So select columns except the last 3. Now, as I said, the indexation in Python works from 0, right? Unless you specify it otherwise. So if you have the columns, this will be 0, this will be 1, 2, 3, 4, and so on, right? Again, I need to do something about my writing. That's a 5, trust me or not. Okay, but we can also count from right to left, and we do it through negative numbers, starting from 1. So -1, -2, -3, and so on. So if we want to look at if we just, for example, want to get rid of one column that is at the far right of our data set, we can do it the following. And we have to get rid of the last 3. So the way we will do it, I'm looking at this, okay. Sorry, I'm still getting lost in all the chats and all that. Okay, so basically we select our data frame, we do the integer location, again we want all the rows, and we want all the columns except the last 3. So for counting from -1, -1, -2, 3. And we can actually test it because we have 32 columns here, so this is potentially correct. We can do a quick assertion where we take euro12.shape. We have the number of columns. We subtract 3 and see what did I do? Okay. True. We should actually get, I did something that is unexpected. But basically, let's see if we can, still the same. Okay, I'm doing something, what am I doing? Chat help. Shape 1, -3, that should give us this, that should give us this. We can just, can't remember now. Okay, it's not really outputting what I want. I'll think about the answer. But basically, we have 32 columns. We'll get back to that once I think of the answer. What I did wrong. Okay. So now, real quick, we'll do the following. Shooting accuracy from England, Italy and Russia. So basically we need to take England, Italy and Russia. So we need to take them from the rows, right? So we need to actually filter twice. We need to filter the column called team, and we need to filter the 3 of the country names, and then take the shooting accuracy. So let's do that real quick. Okay, Euro 12. And again, we're now dealing with text. And so we'll do the location rather than the integer location. And do the following. We need to select the column, Euro 12 team. And we have a function called isIn. And now we pass on a list. So we need England, Italy, and Russia. And Russia, of course. Russia. Okay. And we need the shooting accuracy. Shooting accuracy. Okay. What we'll actually do, we'll take also a team and shooting accuracy. Close this and close this, and I didn't close this method. Okay, so with any luck, we are now safe. So we have now information that the team England had a 50% accuracy, 43 for Italy, and Russia had 22.5. Okie doke. So we're done with this particular challenge. I need to check what I did wrong with this assertion, because I'm not sure why I did that. But we'll get back to that. I still haven't thought of an immediate solution, so we'll get back to that. Okay. And now we're going to deal with the fictional army. And as I change, I'll look at the chat to find out whether there are any questions. The chat's one chat. Fictional. Okay. So far, it's so good. We don't have any questions. Okay, moving on to the next challenge. We'll be dealing a lot more with the filtering and sorting. So let's get on with that. Let's import the data the pandas package, pandas SPD. All right, let's run this, and we need to run this. Okay, so what is going on in the raw data? We have a regiment, then Nighthawks, We have company, deaths, battles, and a couple other things. Actually, since this is a dictionary, we're going to assign it to army. We can do two things. We can change it into a data frame, and pass in just simply raw data as data, and army head. Yep, and it loads in correctly because it already knows that it's your dictionary because it passes it internally. Or tell it explicitly from dict, and then we don't need the data parameter, it just knows, and it does exactly the same thing. Army head, and we're good to go. Okie doke. So set the origin column spelling people column as the index of the data frame. Okay. So let's do that real quick. Army set index. You see how the names of methods in pandas are so commonsensical. Okay, origin. Now, there are two other things that we need to do. We don't want to create a new copy of the data frame, and we need to also drop the original origin column because it will be passed or moved into the index. So the first way, in order to drop the column, we do drop true. And to not create a copy but do it in place, true. And we're good. And what we're going to check, army index, and we have our origin, so where people are from, as our index. So we've done this particular thing correctly. Print only the veterans columns, army, we could use the dot notation, veterans to see, and we have the information right there. Okay. So far, so good. Okay, now print the columns veterans and deaths. So let's do that. And again, this time we need a double square brackets because we're passing on the list. And we also want the data frame potentially. Veterans, deaths. Deaths, and we should have both of these columns correctly. Right? Okay. Print the name of all the columns, so army.columns, and we have the names of all the columns. Again, I'm passing through this real quick because we've seen this in 2 episodes already. Okay, so select the deaths and size and deserters columns from Maine and Alaska. Okay, so again, army. We're dealing with a string, so we're just doing log. And now which rows do I want? I want the rows whose index are Maine and Alaska. So let's do that. Maine and Alaska. And which columns do I want? I want the deaths, size, and deserters. And just wrap that in this and close the log. And we have the answer here. 3 deserters and 24 deserters. I don't blame them, they'll be escaping from Alaska. It's very cold there. So, fair enough. And again, playing around with the log and ilog really quickly. This time we're dealing with numbers. So, let's do that. Army, ilog, so integer location. And again, Python is 0 indexed. In order to get 3, 4, 5, 6, 7, 5 numbers, we need to go 1 down. So we're starting from 2 to 7 and going 3, 4, 5, 6, sorry, so counting is hard. We need to go one value down on the left hand side and keep the values as is, because this will also count 1 down. Okay, so let's close this. Okay, and we should be okay. Yeah, so now we see that these are the origins in here, and these are the columns here. The battle sizes. I wonder what that army actually did and where it fought, although wasn't it called the fictional army? Okay. So, select every row after the fourth row and all the columns. So again, this is a beautiful depiction of what it is that I told you about the colon being the gateway. So if we do iloc, so which rows do I want? We want everything after the fourth row. So this will be enough. So now we give it a limitation on the fourth row, and we let it go all the way till the end. And we want all the columns. This is writing explicitly. We don't really need the second column, the second colon, because it will automatically assume, but we can't really do that with columns. But this will work. And again, by definition, we do iloc, and we limit everything up to the fourth row. So you see, you can compare this colon 4 and this 4 colon to be exact when it comes to what I meant about the gateway and which way the colon actually passes information. And then all the columns, and again this is just for aesthetics. So I'm checking the chat here. Okay. Setting the third column up to the seventh column. Right? So again, army.iloc. We know this already. All the rows, and then 2 to 7. Great. Okay. Now we're back to filtering. So we're filtering army. We're passing the colon, the column, sorry, the deaths that are greater than 50. Yeah. Okay. And now we've dealt with this once, although not in this stream, where we looked at the at the grouping of the filtering, and we'll do that more explicitly here. So we have army. And now we have army deaths are greater than 500. So this will be our first group. And we can actually, I can show you like this. And this will be our second group. Army. What do we want? Deaths as well. Is less than 50. Right, close this, and we have this. You see how the groups are very explicitly not here. No, actually this is clear enough. Just maybe remove this. So you see the two groups. First group surrounded by parentheses, second group surrounded by this parentheses, and our operator. So in this case it's or, this one is or, that would be and what these do is they do the operation element wise. So we cannot explicitly use or and because these are logical operators, and this will not work here. So we need to remember that we use the pipe symbol or the ampersand symbol for the bitwise operations here. But otherwise, I think the groups are clear. We can run this. Okay, really quickly. Select all the regiments. So army regiment. yes, and I did my own trick. I forgot to assign it to a data set, or to our data frame. So army regiment, the bang equals it means basically not equal to dragoons, and we have everything apart from dragoons in our data set. All right, I'm checking the information here. All right, I'm still getting lost in this thing. Okay, so rows called Texas and Arizona, Army, and again we're selecting rows, so we're doing our location, and we need Texas and Arizona. Okay, and we could explicitly say all the columns, but that's really not required because it assumes so from the lack of operation. It's actually cleaner and more aesthetically pleasing to actually put everything, because if anybody's reading your code afterwards, they can actually see exactly what it is that you're doing. But since these are actually such simple operations that this is actually assumed, you don't really need it. Okay, so let's now look the third cell in the row named Arizona. So basically, what we're asked to do, as we have our rows and our columns, we have a row called Arizona somewhere, right? And we want to go to the third cell. So basically we're selecting third column this way. We're selecting third column from this row. So think about this row only. And we're selecting first column, second column. This is the one that we want. So in order to do this, let me switch this off. We need to actually combine the loc and iloc, because we're actually doing both with text and numbers this time. So we're going to do that. Army.loc Arizona. Right? And now the iloc, we want, ironically enough, we've selected the rows. We want all the rows this time because we've already limited our selection here. And we want the third cell, so number 2, 0, 1, 2, 1, 2, 3, 0, 1, 2. And we have our row. This one is with the output of including the name of the index, which actually is more explicit, so we can keep that. And again, select the third cell down. So if we have our data set, cell 1, cell 2, cell 3. So basically row 1, row 2, row 3. So 0, 1, 2. And from the column, deaths. So let's do that. You see, like, you need to think about the broader picture about the entire table rather than just the fact that you're selecting a cell, because actually it might be a lot more overwhelming than you think it is, and you think it might be a lot more complicated, but it really isn't. So we're dealing with now we're going to be limiting the rows in the second expression. So first of all, we'll select all the rows, and we'll select our column deaths, I think, right? And now we're selecting the third column. Okay, so let's deal with this. So integer location, third column, so 0, 1, 2, and all the columns here. Because we've limited the selection of the columns here, so we can easily pass this on, and this will filter back to this. It will look at this method. All right, So we have 25 deaths in Texas. Okay. Any questions that we can potentially see? No, we don't see any questions. Okay. Let me check what the. So we've done this one. Grouping. Okay. I think yeah, because there is a group by methods that I'm going to discuss in great detail next time. I'll pass on these challenges today, so we're going to probably finish the stream earlier, unless there are other questions that you might potentially have. If not, I'll finish now, because I don't want to go into this group by without discussing it properly from a methodological perspective, and there is no point sort of to go through this without discussing the methodology, because it's actually quite a few. There are quite a few interesting things there when it comes to how we go about sorting and grouping and combining and splitting and applying certain methodologies and transformations here. Okay, so are there any questions, dear chat? This video will be available on YouTube as soon as we finish streaming, I think, under the same link. And if you have any questions, you can always leave a comment or ping me directly, and I'll be always happy to answer anything that I can to the best of my ability. If you have any way to solve my little problem with the comparison with the assertion statement of true and false, rather than getting the values in the columns and the cells themselves, then by all means post it as well. So with that, thank you very much and see you next time.